Alright, so let's talk about finding determinants of larger matrices. For 2 by 2s it's easy because we've got that nice little formula. But for larger matrices, we're going to use what's called a cofactor expansion method. And the nice thing about this cofactor expansion method, so as I was saying, we use a method called cofactor expansion, which allows us to find the determinants of any size matrix. It's a little more complicated, but let me show you how it works. Let's first come up with a matrix here, and we're going to work on the 3 by 3 case, and then you would expand this to larger cases as needed. Okay, so the first thing we have to talk about is that we have a thing called a minor. Okay, so the first thing we're going to worry about in this process is finding the minor of this matrix. Okay, so here's how this works. It's fairly simple. The minor of each, let's do it this way. I'm going to do a little lassoing. Copy this, paste it, shrink it a little bit. Okay, so basically here's the idea. Each entry, say the 2, 2, or the 1, 2 entry in this case, has a minor, and we use a 1, 2 to indicate the minor of the 1, 2 entry. And here's what it is. It's going to be -1 raised to the 1 plus 2. Now where did I get 1 plus 2? Right there. I just add the 1 and the 2 there to get that. Okay, raised to the 1 plus 2 times m sub 1, 2. Now what is m sub 1, 2? Okay, m sub 1, 2 is the determinant. Let's write it this way. M sub 1, 2. Okay, m sub 1, 2 is what you do is you cross out the for the entry you're talking about, right? You cross out its column and its row, and you take what's left over. So in this case, you would take the 9, 2, 4, 0 in kind of order, and you want to find the determinant. And so I can use these big bars there to indicate find the determinant. So the minor is simply this idea of taking what's left over after you cross out the row and the column and taking the determinants. In this case, it'd be 0, -8, or -8. And so a sub 1, 2 is simply the -1 to the 3rd power, so -1 times -8, or 8. All right, so let's make sure we get these things right. This is called the minor, and this is called the cofactor. When you take the minor and multiply it by -1 to whatever power. Okay, so let's just do this one more time. Let's do it in blue. Let me erase some things here. Keep that as 6. Okay, so let's find the cofactor of, say, the 3, 1 entry. Okay, so we want to find a sub 3, 1. It's going to be -1 raised to the 3 plus 1. So real quick, look at that. It says, oh, that's going to be raised to the 4th power. So that whole term is just going to be 1. Times the minor, the 3, 1 minor. Now what is the 3, 1 minor? 3, 1 minor is the determinant of, cross out the 3rd row in the 1st column. So this is going to be the determinant of 6, 0, negative 3, 2. Okay, and so 12 minus 0 is 12. So the cofactor, the 3, 1 cofactor is 1 times 12, or just 12. All right, and so that's the cofactor. So each entry has its own cofactor. Okay, and so that's what we are going to be using. We're going to be making use of those cofactors to find the determinant. I'd like to do just one more. Let's just do one more. See if we can just squeeze it in here. No, let's go down. So we'll erase and erase. Okay. So let's find the 2, 3 cofactor. Okay. So the 2, 3. Bam. The 2, 3 cofactor is going to be. So I'm gonna do it right here. Let's see if we can do it. So we'll do it maybe the easier way. So we're gonna go. Okay, a sub 2, 3 is minus 1 to the 2 plus 3 is 5. So that's gonna be minus 1. Okay. And then just a real quick glance, I cross out the row and the column of the entry. So I'm left with 7, 6, 4, 5. And so the determinant of that is going to be 35 minus 24, or 11. And so this becomes a negative 11. Okay? So every entry has a cofactor, right? All right, so to find the determinant of a matrix, any size, you're going to use what's called the cofactor expansion method. So here's how it works. You go to the matrix. Okay, so we're back here now. You go to the matrix and you pick any row and any column. Let's pick the second column, or I should say any row or any column. It doesn't matter. You can pick a row or column. And so here's what's going to happen. The determinant of A. This is the definition. Is simply going to be this, and it's always the same. It's going to be you look at the row or the column you chose. So it's, in this case we chose the middle column, so it's going to be the first entry of that column, 6 times its cofactor, so that'd be the 2, 1 cofactor, or sorry, 1, 2 cofactor, plus negative 3 times the 2, 2 cofactor, plus 5 times the 2, 3 cofactor. And that is the determinant. Okay, it's called the cofactor expansion. You're just taking each entry of a row or column times its cofactor, adding them together, and you get the determinant. So let's do that real quick. So we're going to have, so we need to find 3 cofactors. Let's do that here. A sub 1, 2. Okay, so it's going to be minus 1 to the 3rd power, okay, times the 1, 2. So so we're crossing out that and that, right? So what's left is the 9, 2, 4, 0. So it's going to be 9 times 0 is 0, minus 2 times 4 is negative 8. So let me kill those. So try that again. 9 times 0 minus, so 0 minus 8 is minus 8. Okay, so we'll leave that. Of course, we know that's going to turn into an 8 when it's all told. Plus, now let's take, oh, yeah, no, sorry, we aren't expanding that yet. Come on, where's my eraser? There we go. So this turns into an 8. Okay, now we need the 2, 2 cofactor, right? Because we're just doing this, and this part first. So the 2, 2 cofactor is going to be minus 1 raised to the 2 plus 2, that's a 4. That's good. So that's going to turn into a 1. So that's nice. And then again, I cross out the row in the column of that 2, 2 entry. So 7, 0, 4, 0. So 7 times 0 minus 4 times 0 is 0. So 0. So we get a 0 there. And then finally we need the a sub 3, 2 entry. So cofactor minus 1 to the 3 plus 2. That's just going to be a negative 1. Cross out the column and row. 7, 0, 9, 2. 7 times 2 is 14 minus 0. 14 is the answer there. And so minus 14. Okay, so we're ready. Our determinant is simply going to be 6 times a12 plus a negative 3 times 0 plus a 5 times a negative 14. So what's that? 48 plus 0 minus 70. Yeah, so minus 70. And so what's that? A negative 22. Negative 22 is our determinant. Now, let's do it again, but let's use a different row or column, right? Because I maybe need to convince you that this method works. Because remember, our very first choice is to choose a row or a column. It does not matter which to choose to expand along. Okay, so let me give you right now a good tip. Pick a row or column with lots of zeros in it. So in that case, I'm going to use that row or that column. So the determinant, according to our cofactor expansion rule, should be this. The determinant of A should be 0 times the 1, 3 cofactor plus 2 times the 2, 3 cofactor plus 0 times the 3, 3 cofactor. So as I said, choose a row or column with zeros in it, because what's going to happen is that's going to be 0. 0 times whatever a sub 1, 3 is 0. That's going to be 0, right? Those two terms disappear. So all I need to figure out is 2 times a sub 1, 3. So let's squeeze that in here. Let's find a sub 2, 3. So it's going to be minus 1 to the 2 plus 3. So that's going to be a minus 1. And now I need the minor. Remember, I'm using the 2, 3, so that means I'm canceling out that column and that row. So 7, 6, 4, 5. And so when I take that, it's going to be, I'll write it down, 35 minus 24. Right? And so that should turn into a minus, or an 11, right? Okay, so look at this. According to our little rule here, this should be 2 times, that'll be a minus 11. That'll be a minus 11 because of the negative 1 out in front. So negative 11. So it's going to be 2 times negative 11. Getting ahead of myself. Negative 11. And look at that, negative 22. So it does not matter which row or column you expand upon. Okay, but choose a row or column with lots of zeros, because then you get your work's a lot easier, because you don't need to worry about finding these those cofactors, because they're just going to be zeroed out anyway. Okay, so this method works for any size of matrix. All right, now when it's a 3 by 3 matrix, the minors are going to be 2 by 2, right? You cross out one column and cross out one row, and so you're going to be finding the determinant of a 2 by 2 matrix, right? If it's a 4 by 4 matrix, then you're going to cross out a row or column, and you're going to be left with a 3 by 3 matrix that you got to find a determinant of, a 3 by 3 minor. So you got to find the determinant of that 3 by 3. And so think about that for a second. How do you find the determinant of a 3 by 3? Oh, you end up finding the 3 minors, right? The cofactors of you find the determinants of 3 2 by 2s. So you can see that it's really complicated to find by hand determinants of anything above size 3. Size 3 is manageable. We can do that by hand. But size 4, you're going to end up by taking 4. You need to calculate 4 3x3 determinants, and for each of those 3x3 determinants, you're going to need to calculate up to 3 2x2 determinants. So it's a lot of calculation. So we will rely on technology for anything bigger than 3.